In this video, we'll be visualizing the ice cubes and hot water temperature values on Grafana dashboard using MING stack and ESP32. MING refers to MQTT, Influx, Node-RED and Grafana. So here is the flow that we can use to send the data. First, we'll be using DS18B20 sensor, which is in waterproof probe format, and this sensor is interfaced with ESP32, and then we send the data using MQTT to the MQTT broker. And MQTT broker values are being subscribed in the Node-RED, and in the Node-RED we also send the data to the InfluxDB, and InfluxDB will be storing these values of data that we are sending in a time series format, and then we can use Grafana to showcase the time series graphs or some kind of visualization dashboards that we want to use. In my previous video, you have seen how to connect the DS18B20 temperature sensor with ESP32. Here you can see it again, how to interface and use these wires and 4.7 kilo ohm resistor to use it, and how it realistically look. So this is how you need to connect it. Once you have connected, you can directly open Arduino IDE. So in the Arduino IDE, this is the updated code. So here, as previously used, I'm using this Arduino MQTT client. So that is the library. If you don't have that, you can install from library manager, and then you can use your SSID and password. And here MQTT broker that we are using is emqx.io, and we are using 1883 port, and the topic is IoT frontier, kitchen and refrigerator. And remaining code, you can see it is just a boilerplate code. We are initializing the clients, and then in the setup you can see we are connecting to the Wi-Fi, and in the loop you can see this poll command is used regularly so that you can send this keep alive packets, so that you can manage this connection of MQTT and it doesn't disconnect. And we use other functions like getting the temperature and reading them and sending them as a JSON document. And you can see how we are sending into this MQTT client and also showing in the serial monitor. So once this is done, you can connect your ESP32, and if you have connected ESP32 onto your computer, you can select the board. So you can select ESP32 dev module if you are using that, and the COM port, and click on OK. And once this is done, you can see in the below corner as well that ESP32 on COM3. Next thing, you can click on upload. In the meanwhile, what I can do is I can open Node-RED. So go to run and type node-red. So it will initialize the Node-RED. In the meanwhile, you can see Wi-Fi is connected and it is trying to publish the JSON in this format. And if you don't have Node-RED installed, then I suggest you to watch my previous video on how to install Node-RED from the top right corner or in the description below. And here you can find the Node-RED IP address. Use Control and click this, so it will open Node-RED. So you can click on plus to create a new flow, and first thing that you need to do is take MQTT in. So once you drag this MQTT in, double click on this, and you can see add MQTT broker is there because you don't have any broker. So in that case, you can click on edit icon and then paste this broker of emqx.io, and the name also the same, and you're not using any security username and passwords, so I'm keeping everything blank, and click on add. And the topic you need to copy from your Arduino IDE code, and the QoS you can keep either 0 or 1, doesn't matter right now, and click on done. So next thing is we need to have debug node to test whether we are getting the values or not. So deploy this. So you can see the values are being shown as a JSON object here. So 281875 is being sent every 10 seconds. So next thing that we can do is we can send to the InfluxDB. To send to the InfluxDB, we need to add that palette. So go to palette and search for Influx. So you will see Node-RED contrib InfluxDB. So you need to install it from here. Click on that. I have already installed it. So once you have installed it, you can see Influx here. So you need to use influx out. And To send to the InfluxDB, we need to format the data that we are getting in this format. So for that, we use function app. So use this function app in between. So this is how we want to send, and in the function app, you can mention as transform to influx format. So here you can paste the code. This is a simple JavaScript code, and here we are taking the variable of temperature value and taking the value of message.payload.temperature, and we have message.payload.sensor also. From here you can see the sensor, temperature and unit. I'm just extracting this sensor value into sensor name constant, and message.payload I'm trying to update with temperature is temp value, and message.tags we can see device. This is the constant that I have given, and sensor type is sensor name, and directly returning the message. So click on done and deploy. Now we have to update this InfluxDB as well. You can click on this, and you might not see anything here because you might have not seen anything previously set. So for me there is already one, so I'll try to delete this. Now you can see you don't have any InfluxDB configuration. So first you need to go to Google and type InfluxDB, and here you can see InfluxDB Cloud. So click on InfluxDB Cloud. So you need to first create an account by clicking on start. I have already created an account, so you can just log in. And so this is your free InfluxDB Cloud serverless account, and there is no need of credit card required, so you can use that. And right now I'm using Google. So this is how you can see the home page. So here you need to first create some buckets. So go to bucket, create a bucket called IoT Frontier, and you can keep never delete or delete older than 30 days as a retention. So then create it. So you can see IoT Frontier. And next thing that you need to do is you need to click on this icon and go to API tokens. So here you need to generate one API token with custom API, where you want to give only permission of IoT Frontier read write access. So then generate. So you need to copy this value, that is API token, and this will not be again shown. So this one you need to copy and then go to here in the Node-RED. So it will ask you to create new InfluxDB config node. So select 2.0 because that is the latest version that we are using in the cloud, and the token you can paste first, and in the URL you need to copy from the URL from the top. So take until the .com and paste it here, and here you can mention InfluxDB Cloud. So click on add, and in the organization, whenever you first create, so from here you can see organization and you have org. So that is one org that you have. So you can go org, and in the bucket I'll use IoT Frontier, and measurement, this is kind of table that we want to create, and bucket would be like a database. So measurement I'll use fridge underscore telemetry, and in the time precision I'll keep it as default and click on done. So I can give the name as well, InfluxDB Cloud, and done. So it will be shorter, and now deploy it. So now we will go back to the buckets. So click on this icon, go to buckets, IoT Frontier, and here you need to select a bucket. So first IoT Frontier, and measurement is already populated because the values are being sent to the InfluxDB. If you don't see this, wait for 10 seconds or more, then you will see this automatically. If not, then you need to try again creating that InfluxDB configuration node. Maybe the API token or some other things might be an issue. So you can recreate them. So now I'll select fridge telemetry, and under the fields you can automatically see the field as temperature. So I'll select this. When I select this, you can automatically see the script is being selected, because when I was creating this InfluxDB, I have selected SQL query language instead of Flux query language. I have used SQL. But if you have selected flux, that is also not an issue. So because it will automatically populate from here. Now click on run. Now you can see from the past few seconds, the values are being populated and being shown here. So the data is being flown to the InfluxDB as well. So next thing that we need to do is Grafana. So go and type Grafana Cloud. So go to the Grafana Cloud official one, click on this. You can create a free account. So I have already created, so I'll just sign in and use my Google. So the instance will take some time to be prepared and it will be started. Now, first thing that you need to do is go to the data sources on the connections tab. In the left side, you can see connections and you need to click on data sources. And here you need to add a new data source. So once you do that, you can search for InfluxDB. So click on that InfluxDB and then the name can be anything. So you can use InfluxDB2 because I have already one that is already created for testing. So I'll use InfluxDB2 and so URL I need to provide, right? So you need to go to the InfluxDB, go to the URL and paste that. And product, you can say Influx Cloud Serverless, and query language, you can use Flux or SQL. So I'll use Flux here, and org is my org, and bucket is IoT Frontier. So you can check these from your InfluxDB, and token you need to enter which you have copied previously. And once this is done, you can click on save and test. So here itself you can see whether data source is working or not. One bucket found means it is working properly. So next thing is you need to go to dashboard. So click on this and you need to click on new dashboard. And if you click on new, you can see add visualization. So here first we need to search for Influx, and here you can search for Influx2 that we have created recently. Select that, and here you need to paste some Flux code so that it will read from your bucket. So I'll paste it. So here you can see bucket IoT Frontier, range from time, range start and stop. The filter, we can see the measurement we have is fridge telemetry and yielding the result. So you need to click on this query inspector first to refresh. So you can see all 41 rows are available. If it is not available, then there is something mistake in the bucket or in the measurement. And now what you can do is you can just use time series for the first time, and you can leave everything as normal, and in the panel name you need to provide something. So we can mention temperature, refrigerator temperature, and the range also we can try to give. So it automatically changes the range, but if you want to put the range, then soft minimum is -10 and max I can put 80. Now you need to click on save dashboard. So you can provide your name, IoT Frontier dashboard, and you can see the values being shown here, and you can change here. For the past 15 minutes, you can see the temperature is very constant. Go back to the dashboard and you can add another panel. So you can click on add visualization. So you can search for gauge, and here also in the data source you need to select InfluxDB2, paste the similar value of Flux query, click on query inspector, and here instead of 60 rows, if you want to get only the latest one, you can use last, and you can see only one row. So now we can save this dashboard. First we need to give the name. I'll give the same refrigerator temperature and save the dashboard. And this is how it looks in the dashboard. So in the top you can put auto refresh. So every 5 seconds this will be refreshed. Now we'll do the real experiment. So right now you can see 28.3. I'll put it in the hot water. Now the sensor probe is in hot water, and let's see how fast it will be reacting. So now we can see 56.1. So for the sake of this experiment, I'll just update my code to send it instead of every 10 seconds, I'll send it 3 seconds. Now we can see every 3 seconds the value is being sent. So here also every 3 seconds we can see the updated value. The temperature has gone above 63 because of the hot water. So if you want to edit this refrigerator temperature, which to show the different colors, you can go to edit and keep this as 50, and I'll try to keep this in this way and go back to the dashboard. You can see 60 degrees Celsius. Now what I'll try to do is I'll try to give it a shock by placing it in the ice cold water where I have ice cubes. So immediately it has dropped. So you can see the accuracy of the sensor and how fast it is reacting. So it is now going to the blue color also you can see, and the graph is also drastically decreasing. Now for the sake of graph, I'll try to again put it in the hot water. So within seconds you can see this is getting into uptrend and the values are being changed immediately. And for the last time, I'll keep it in the ice cube water. And that's all for this video. This is how you can visualize the ice cubes and hot water temperature values on Grafana dashboard using MING stack and ESP32. If you found this video informative, please type helpful and smash that like button. In the upcoming video, I'll show you how to interface this sensor with Raspberry Pi 2W. If you wanted to learn IoT from scratch, then you can check out my course on Udemy from the link in the end screen and the description. Your support means a lot to us and helps us keep creating more content like this. So please subscribe to the channel and hit the bell icon. Thank you for watching, and I'll see you in another interesting video.